In today's session, we are going to discuss about pesticides. Before going to that topic, just recall what you have studied in the previous session. In the previous session, we have seen the production of calcium phosphate from low-grade phosphate rock. The calcium phosphates are of three types. One, superphosphate, another one, triple superphosphate, and sodium tripolyphosphate. Superphosphate is made by reacting ground phosphate rock which contains 35 to 30 to 35% phosphorus pentoxide in it with sulfuric acid which produces superphosphate. We have seen the production of superphosphate, its flow sheet. In the process, the phosphate rock is ground in jaw crusher and then finally ground to pass 100 mesh screen in a tube mill or in a ball mill, and then it is fed to a feeder where the sulfuric acid is mixed with it and then fed to a reactor. The reactor is just like a screw conveyor. Both the reactants, that the powdered calcium phosphate and sulfuric acid, are actually fed into the trough, and it is actually conveyed to the another end. During that period, the reaction will takes place and superphosphate is formed. The fumes of carbon dioxide and hydrogen, which are hydrogen fluoride, which are formed, are taken out as a gas stream, and it is scrubbed with water to separate the carbon dioxide and hydrogen fluoride, which can be further processed. The superphosphate thus formed is actually fed to a storage bin to complete the reaction between phosphate rock and sulfuric acid, and then it is fed to a granulator. The granulator, the addition of water and finely ground superphosphate powder are added to the tumbling solids so that when the rotary granulator rotates slowly, it actually the granulation takes place. The granules are taken out and dried in a rotary dryer, and the superphosphate obtained is then bagged. This is about the production of superphosphate. In the case of triple superphosphate, here the phosphate rock is treated with phosphoric acid, which produces triple superphosphate. The triple superphosphate contains three times more than that of superphosphate of phosphorus pentoxide content. The pentoxide content in the triple superphosphate is three times more than that of superphosphate. Hence, it is called as triple superphosphate. Here, the phosphoric acid and the ground phosphate rock are actually reacted in a belt reactor where the reaction takes place and triple superphosphate is formed. Here also the water content and the hydrogen fluoride is present in the rock phosphate are actually obtained in the form of fumes. These fumes are scrubbed with water to separate hydrogen fluoride water. The hydrogen fluoride is further processed. The triple superphosphate thus formed is then granulated in a rotary granulator, dried, and then packed. In the case of sodium tripolyphosphate, here sodium carbonate is treated with phosphoric acid, which gives sodium tripolyphosphate. We have seen the flow diagram and the process that is taking place in the production of sodium tripolyphosphate, their properties we have seen, and the applications of superphosphate, triple superphosphate, and sodium tripolyphosphate. Sodium tripolyphosphate is mainly used in the production of soap and detergents as fire retardant and in other chemicals. Superphosphate and triple superphosphates are mainly used as fertilizers. In this session, we discuss about the production of pesticides. Pesticides make up one of the essential segments of agro-business complex. Pesticides are used to protect food loss due to the destruction caused by various pests, insects, weeds, rodents, etc. Two types of pesticides are synthetic organic pesticides, which are chlorinated compounds like DDT, BHC, etc. Second one is organic phosphorus compounds like parathion, sevin, saigon, malathion, etc. All pesticides are spread externally to destroy pests. Some of the newer organophosphorus compounds acts as a systemic insecticide. That means they are actually fed to the plant or animal and in the inner circulatory system. And when the pest comes in contact with plant or animal, it will be destroyed. Fungicides are active compounds against fungi. Some plants rust, root, and stem roots, mushroom, and allied form capable of destroying plastics, plants, fabrics, and thus depriving valuable food and materials. Fungicides for plants acts by direct contact and often injure the plant as well as fungus. There are two types of fungicides. One, inorganic fungicides. Elemental sulfur or compounds of heavy metals such as copper once dominated the field of inorganic fungicides. Because of pollution problems, they have been cancelled. Nowadays, Bordeaux mixture, that is, a mixture of copper sulfate and hydrated lime, is an important fungicide. It is very simple in preparation and application and can be made into various formulations. Copper sulfate and hydrated lime are dissolved in water completely and mixed in a required quantity of water, which gives blue gelatinous precipitate suspended in water. It is most effective for most ordinary molds and mildews. It is commonly used to treat fruits and vegetables. Another type of fungicide is organic fungicides. This is this vary in composition. They may be classified as carbamates, chlorinated phenols, and carboxylates. Next to sulfur, nitrogen is the most effective constituent element of an organic fungicide other than carbon and hydrogen. The first fungicide is formulated is formaldehyde, which is about 40% aqueous solution of formaldehyde and is called formalin. Formalin. Dithiocarbamate is made by reacting carbon disulfide with an amide to form a dithiocarbamic acid. This acid is treated with alkali metal hydroxide to give a stable salt of ethylene by bisodium thiocarbamate is employed with zinc sulfate and lime. It is used to combat vegetables, particularly of potatoes and tomatoes. Next, we'll see the production of 2,4-D, that is 2,4-dichlorophenoxyacetic acid. Raw material, dichlorophenol, monochloroacetic acid, and sodium hydroxide. It is required to neutralize the acidity of the finished product. Chemical reactions, chlorination of phenol to 2,4-dichlorophenol, that is C6H5OH plus Cl2 gives Cl2 C6H3OH plus hydrogen. The second step is conversion of 2,4-D, that is dichlorophenol, to sodium dichlorophenoxide. The reaction is Cl2 C6H3OH plus NaOH gives Cl2 C6H3ONA plus H2. The third step is chlorination of acetic acid to monochloroacetic acid. CH3COOH plus Cl2 gives ClCH2 COOH plus HCl. The last step is the reaction between 2,4-dichlorosodium phenoxide and monochloroacetic acid. This is the flow diagram for the production of 2,4-D, that is 2,4-dichlorophenoxyacetic acid. Let us see the process. The manufacture of 2,4-D involves 2,4-D means 2,4-dichlorophenoxyacetic acid. Chlorination of phenol to dichlorophenol, and the reaction products are distilled to produce pure dichlorophenol. This is then treated with sodium hydroxide to get sodium dichlorophenol. In the second step, acetic acid is chlorinated to give monochloroacetic acid. Dichlorophenol is fed into agitated jacketed shell reactor with sodium hydroxide, where the reaction produces dichlorophenoxide. The chloroacetic acid is added and reacts with the evolution of heat. The reaction is carried out at a temperature range of 60 to 80 degrees Celsius and takes 6 to 8 hours to complete. The products are then passed pH adjustment tank and then to a steam still where the unreacted phenol is separated from the mass at the bottom of the reactor. The acidified and with HCl, then filtered, solidified by cooling, dried to get crystalline product. This is the process which is taking place in the production of dichlorophenoxyacetic acid. Next, we will discuss about production of parathion. It is another organic pesticide. The raw materials required are diethyl phosphorochlorothionate. Second is sodium phosphorus nitrophenoxide, that is sodium paranitrophenoxide. Phosphorus containing reactant can be made by PCl3. The reaction is ETO2, that is diethyl phosphorochlorothionate, and PSCl2 plus NaO C6H4NO2 gives parathion, that is E2 ETO twice PSO C6H4NO2 plus NaCl. This is the reaction taking place in the production of parathion. This is the flow diagram for the production of parathion. All the raw materials are fed to the reactor. Reactor is provided with an agitator to maintain uniform mixture, which is actually provided with the jacket to avoid or to avoid excess heat that is produced by exothermic heat of reaction. The products are then filtered, then separated, that is aqueous layer is separated from the separator, and the oily layer is actually taken, washed in a tower with dilute sodium carbonate or soda ash, then it is washed with water, then it is subjected to distillation. So the bottom product obtained in the distillation is settled and the product is taken out dried. It is the process. The reactants are fed into a stirred jacketed kettle as shown in the flow diagram or flow sheet. The solvent may be an alcohol or benzene or chlorobenzene may be used. Copper powder may be used as a catalyst or the reaction can be conducted in a copper reaction vessel, thereby shortening the reaction time. Usually catalysts are used to accelerate the rate of chemical reaction. The yield of parathion is about 90% or higher. The crude reaction product are pumped through a pre-coated filter to remove gummy impurities. The filtrate is separated into an aqueous layer and a heavier oily layer. The oily layer is washed with sodium carbonate solution and distilled to remove unreacted materials. The final product is dried in a vacuum dryer. It is a yellowish thick liquid which is formulated into with dust for agriculture applications, or else it can be used for emulsification. Thank you. Now we'll see few key questions before we closing it. Fungicides or fungi and insecticides are dash. That is, A kills the insect when they eat it. Option B emit poisonous vapor. C are absorbed throughout throughout the plant, and D none of these. Option is correct option is option B. It actually emits poisonous vapor. Question number two, systemic insecticides dash. Options are option A are absorbed throughout the plant. B kills insect following external body contact. C are stomach poisons, and D emit poisonous vapor. The correct option is option A. Systemic insecticides are absorbed throughout the plant. Question number three. Example of inorganic pesticide is dash. Option A, Bordex mixture. Option B, DDT. Option C, Parathion. Option D, 2,4-D. Option A is the right answer. Next question is to reduce the time of reaction in Parathion production. The reaction is carried out in dash reactor. Option A, copper. Option B, iron. Option C, aluminium. Option D, stainless steel. The right answer is copper. Copper powder or is added, or the reaction itself is carried out in copper reactor to accelerate the reaction. Next question. In the production of 2,4-D, the reaction temperature is maintained in the range of dash 30 to 40 degrees Celsius, B 40 to 50 degrees Celsius, C 60 to 80 degrees Celsius, and D 80 to 90 degrees Celsius. Correct option answer is option C 60 to 80 degrees Celsius. We have discussed in this session about the production of 2,4-D and Parathion. These are all organic insecticides which are used to protect food materials. In India, actually, up to 10% of the total food production is wasted or lost because of the insecticide, fungicide, insects, rodents, etc. Thank you.